Welcome back to part 10 of our DIY Autonomous Mobile Robot Building series. If you missed parts 1 through 9, check out the links in the description below or access the full playlist at the end of this video. In this video, part 10, we'll continue making progress with the chassis design. So let's dive right in. We'll begin by duplicating the inner wall. Start by selecting the inner wall in the browser, then use the Move Copy tool, making sure to check the Create Copy option in the Move Copy palette. Move it by 26.4mm plus the 3.7mm thickness of the HDPE board. And you'll now have two inner walls on either side of the 9V battery and the caster wheel guard. Switch to the top view and note where the 9V battery wires extend. So I've selected the outer face of the right inner wall. Now press P and select the peripheral shape surrounding the 9V battery wires and also the lower wire here. We'll make a 3mm circle, draw a line segment, make it tangent to the circle, and make the end of the line segment coincident with the circle. Copy that line segment and make it tangent to the circle on the other side. Use the parallel constraint and then finish sketch. Select the entire slot and extrude it by 3.7mm in the cutting direction. Now you can see the slots on both sides as the wall is a copy of the other. Now switch to the top view and create a new component. I labeled it M6 18x1mm washer. Okay, let's create a sketch on top of the hex nut of the caster wheel. Press P to project the vertical shaft diameter, which gives us the center as well. Make a 6mm inner diameter and a 12mm outer diameter. So this is not an 18mm diameter as I mislabeled the component. Finish sketch and extrude the washer by 0.5mm. Again mislabeled as 1mm. Let's use a fillet of 0.1mm on either side. We'll just scoot over to the HS311 servos and add the remaining servo grommets by copying and inserting them using the joint operation. Now let's measure the distance between the center line and the inner face of the grommets on one servo, which measures 36.65mm, and likewise measure the distance between the center line and the inner face of the grommets on the other servo, and that also measures 36.65mm. Let's unhide the body and create a new component. Label it outer wall. Okay, with the outer wall activated, select the inner face of one of the servo grommets and add sketch. Let's swivel the sketch around. Switch on analysis. Now create a rectangle centered on the origin, making sure it's large enough to cut through the robot body shell. I used 220x130mm, which is more than big enough. Finish sketch and extrude the rectangle by 3.7mm, matching the HDPE board thickness. And that's the start of the outer wall. But of course we're going to have to trim the outer wall. Use the Combine tool, selecting the rectangular wall as the target body and the robot body shell as the tool body, then hit OK. Now in the browser under outer wall you'll see two bodies. Just hide body 2, and if you hide the robot body shell you'll see the newly cut outer wall. Select the outer surface and do another extrusion of 3.7mm, but this time select intersect so that only the extruded part remains. Unhide body 2 and remove it. Now let's copy that and move it by 73.3mm plus the wall thickness of 3.7mm. Next, let's look at the eyelets. These fit into each servo grommet and a screw is inserted through them to mount the servo. The step file for this eyelet is available on my GrabCAD account. Check the description for the link. Each eyelet has a 2.4mm inner hole diameter, a 3.0 outer diameter for the small protrusion, and a 5.0mm overall outer diameter. Let's insert the eyelets into our design. We'll need a total of 8 eyelets, 4 for each servo. Make 7 more copies and use the joint tool to attach the eyelets to each servo grommet. Now each servo has grommets and their respective eyelets attached. Now let's work on the outer wall. So activate it. Select the outer surface and create sketch. Press P to project. Select the face to project the entire outline of the outer wall and project the inner diameters of the eyelets. Let's make some little 1mm holes to help the self-tapping screws along. We also need to form a rectangular hole for the servo body to fit through. Press P to project and just swivel the design around to help us select the servo body. Swivel it around the other side to select the outer side of the servo body. Select the upper and lower sides too, and there we have all 4 sides projected onto the current sketch. Hide the servos for now. Here I have a line segment that I have made parallel to one of the projected sides, and let's apply a dimension of 1mm and do the same with the other sides. Just close the corners using the coincident tool. Actually, I ended up adjusting the dimensions from the side to 0.5mm instead. Finish sketch. Select the rectangle and each 1mm hole. Swivel the design a little and extrude by -3.7mm, which will cut through the wall. Now we'll just zoom in and select this corner to do a fillet operation. Set the fillet to 0.5mm. Swing around to the next corner. We'll need to hide the wheel spacer to select this corner, then select the remaining 2 corners in the same manner. And there we have a rectangular hole through which the body of the servo can fit. Now unhide the wheel spacers and servos. Let's turn the whole design around and we can see that the exact same holes have been formed on the other outer wall because the other outer wall is a copy of the first one. Here's a view with the first outer wall hidden so we can clearly see the battery holder. Select the battery holder and then select move. So I'm just moving the battery holder temporarily to visualize the removal of the battery holder to determine how much tolerance we need. We'll just cancel that to revert back to the previous position. So we want to have some sort of hook or catch at the rear end of the battery holder. I initially sketched out a hook shape as an extension of the inner wall, but as you can see, upon extruding this shape, it became obvious that there isn't enough material for creating a strong enough hook. Before we deal with that problem, let's first conduct a visual check to see whether the shape of the hook will allow the battery holder to be removed. And there we can see that there is enough room for the battery holder to rotate down and out from the underside of the robot. Just hit cancel to revert back to the inserted position. Actually, I might reduce the angle of the straight edge here just to close up the gap a bit. Now let's zoom in at the rear side, viewing along the outside plane on the inner wall, and we can see that the plane is on the outer side of the caster wheel and does not interfere with the caster wheel. So I decided to create a subwall that lies on the outer surface of the inner wall so we can delete the extrusion we just made and hide the sketch. Instead, let's create a new component and label it Battery Pack Rear Hook. Select the outer surface of the inner wall and create sketch, and unhide the hook sketch we created a moment ago to reveal the hook shape. Press P to project the shape of the inner wall and the hook, and then select conic curve from create. Connect these 2 opposing points on either side of the caster wheel, and I've set the reference point of the conic curve to 4.5mm from the center of the caster wheel. Next, we'll extend a vertical construction line from this point on the hook to a horizontal line that was projected from the inner wall. From there, we'll draw a solid line to a random point here. Make it tangent to this half circle and make the endpoint coincident to the half circle too. Finish sketch. Now select all the portions of the rear hook we are creating and extrude by 3.7mm. Activate the main design, and just to visibly distinguish between the inner wall and the rear hook, color the inner wall by pressing A and dragging a white pigment onto the inner wall. So there we have the left hook on the left side. Now make a copy of that for the right side. But first we'll measure the distance between the outer faces of the left and right inner walls. In my case, I get a distance of 33.8mm. Okay, so select Battery Pack Rear Hook on the browser, select Move Copy, select Create Copy on the Move Copy palette, and drag the copy by -33.8mm plus the wall thickness of 3.7mm, which is a total of 37.5mm. This brings the copy of the rear hook onto the outer side of the right inner wall. Unhide the robot body shell, and we can see that a portion of these hooks actually penetrates through. Hide the robot body shell again, edit the sketch. I created a new construction line that intersects the rotational center of the servo. Delete the conic curve we previously created and create a new conic curve from the center line that extends through the center line of the servo. Finish sketch. Now we need to edit the extrusion from the timeline. Unselect all the profiles and only select the profiles you want to extrude. Hide the sketch and unhide the body shell again. Unfortunately, there still is a little corner penetrating through the body shell. A section analysis will give us a better visual. Yes, here we can see the problem very clearly. It's actually the inner wall that's poking through, not the rear hook. Apply a fillet on the corner here. 10 millimeters should be more than enough. Unhide the robot body shell again. Nothing seems to be poking through now. Switch on the section analysis to check. And as we can see, the inner wall no longer interferes with the body shell. Let's hide the left outer wall, tilt the robot sideways a little, and create a new component. Label the new component Base 001. Create an offset plane from Construct, and select the underside of the battery holder for the position of the offset plane, and create a new sketch on this plane. I like to orient the sketch this way. Press P to project some of the components onto the sketch. Select the inner side of the outer wall. We'll need to unhide the outer wall too. Select the other outer wall in the same manner. We'll also select some edges of the left and right servos, mainly for reference purposes. Start sketching the base by sketching a line parallel to the projected inner edge of the outer wall. Then use the dimension tool to set the clearance between these two lines to 0.4 millimeters. Now mirror that line about the central axis. Dimension this line at 54 millimeters. Sketch a center line towards the front and sketch a solid line from the top edge to this center line, and mirror the solid line about the center line. Connect the two rear ends of the two parallel lines with a rear solid line. Finish sketch. Select the profile of the base and extrude by 3.7 millimeters. I'll just activate the entire design. Hide the left outer wall. Let's have a good look at the base we've just extruded, and we can see that it sticks out at the front side from the outer wall. Unhide the robot body shell, and we can see the front corner of the base penetrating through the body shell. Switch on the section analysis, and we can also see the rear end of the base interfering with the servo. So let's get back to the sketch of the base and edit sketch. Actually, I decided to tighten the tolerance at each side to 0.2 millimeters, so a total of 0.4 millimeters. We'll also need to create an opening to allow the circuit board to go through. Press P to project and select each side of the circuit board to project those lines onto the current sketch. Next, we select those projected lines that define the thickness profile of the circuit board. Then select the offset tool, and the offset tool automatically sets the offset position to 1 millimeter, but we'll set the offset to 0.5 millimeters. Next, we'll need to shorten the length of the base, so I'll shorten it by 10 millimeters down to 44 millimeters. Finish sketch. Immediately we can see that the front of the base has shortened. Now we need to extrude the opening for the circuit board. Here's the base with the opening already extruded out. I don't have the footage for the actual extrusion operation, but make sure you hide the circuit board when you do the extruding. Next, we'll deal with the rear end of the base that currently interferes with the servos. Hide one of the servos, zoom into this top corner, which is interfering with the servos, and select the corner. With the corner selected, we can move to the side elevation and perform a fillet operation. A 1 millimeter radius wasn't enough, nor was 1.5, so I settled for a 2 millimeter radius. Okay, so I don't like where the position of the self-tapping screw is relative to the thickness of the base. It would have been fine if the screw was aligned exactly in the middle of the thickness position of the base, but it isn't, so we'll carve out an opening in the base to to make way for the screw if needed. So go back to the underside and edit the sketch again. I put in a 10mm construction line, though you can't really see the line itself, then a 7.5mm vertical construction line. From Create, select Slot and create a 10mm center to center slot with a half width of 7.5mm. That slot isn't constrained, so we'll make the half width of the slot coincident with the 7.5mm dimension. This works until you use the cutoff tool to remove the excess lines of the slot, but that can be easily fixed by adding a few dimensions with the dimension tool. Now mirror that shape about the central axis, activate the base and cut those shapes out with Extrude. We probably don't need to have that large a space for the servo screws. Edit the sketch again, adjust the width of the slot to 4mm and also the radius. Finish sketch. And there we have the base with the left and right openings adjusted according to the sketch. Unhide the servo. I'll just hide the left outer wall to get a better look. Let's color this white for better visibility by pressing A and dragging a white color onto the base. To continue, click here for part 11. If the link isn't showing, part 11 isn't quite ready. Check the description for my upload schedule. Thank you for watching.